Hello everyone, my name is Andrew. Today we'll continue learning Python and today we'll talk about object-oriented programming versus functional programming. So let's start. But wait, before we start that video, I recommend you checking out my new course. There are lots of errors, lots of mistakes that many programmers make, and I decided to create a new course that sums up all of these errors, all of these mistakes, and gives you real solutions on how you can improve your code, improve your structure, your business, your company, and so on. And if you want to write better code today, then just check out that course. I, of course, mentioned lots of things in my YouTube videos, but if you want to get into details, then that course is for you. So just check it out, link is in the description, and let's continue with the video. Once again, today we'll talk about object-oriented programming, so classes and objects versus functions, so define functions and that stuff. And we're going to answer 3 of those questions. Well, those are not really the questions, but we're going to solve 3 of those tasks, or we're going to finish whatever. So first of all, let's talk about object-oriented programming and functional programming. So functional programming is simply when we write functions, so define func, which calls func2, which is called in main as func, and so on. So we write everything using functions. And object-oriented programming is when we write everything using classes. So for example, class player, which has name as something, then HP as 100, and then we have a method called func, for example. Yeah, so that is object-oriented programming versus functional programming. So the first question or the first idea is finished. The second one is what is better. So actually there is no answer because neither functional programming or object-oriented programming is better. So both of them solve the same task, but they solve it differently. So the ideas are the same, that's what I meant. Both of them tell you how to write your code, but you can use both of them for different cases, and for each case there is a better thing. But in general, object-oriented programming or functional programming are equal to each other. So let me give you an example. There is a framework in Python called FastAPI. So FastAPI allows you to write web applications in Python, and FastAPI uses, well, actually it uses object-oriented programming inside of it, so the framework itself is built using classes and objects. But if you're talking about our code, so the code that we are going to write using FastAPI, then what we can do is use functions. So for example, API get and list all users, and that will be a function that will get something and that will return something. And also there is another framework called, so that is functional programming in terms of web development. And also there is another framework called Django. I don't have it installed, but the idea is the same. So we use class, user, list, view, which inherits from a view and which has get function or get method inside of it. So the idea is the same, but as you can see, we can solve the same ideas or the same riddles using different styles of coding. Okay, so we can use either functional or object-oriented programming. So there is nothing that is better. So no functional programming or object-oriented programming is better. So yeah, those are kind of equal. Okay, so interesting things in Python. What is that? And that is the most interesting idea for today, is that in Python there is no object-oriented programming is almost equal to functional programming. So what do I mean by that? Everything in Python is an object. So when we write a function, func, we can use it as an object. So if I just print the name of the function, I can use it as an object. As you can see, function func at something. I can use dir to get everything that is located inside of that function. So as you can see, annotations, call, class, it even has class. Let me just quickly do it like that. Class dot name, like that. Let me just run it. As you can see, class function. So actually everything is an object. So what does that mean? That means that we can actually use our functional programming with the ideas of object-oriented programming. And the main difference that I forgot to tell you about between functional programming and object-oriented programming is how we handle our data. So when we're talking about object-oriented programming, we have a class called player, for example, player. And that player class, what does it have? It has name, for example, then x coordinate and y coordinate, something like that. But what is the most interesting idea is that we are using states. So the object-oriented programming is stateful. That means that we save the data in some places. So in our case, player1, which is player, is an object. Player1 is an object that has some state, has some data which is related to it. In our case, it's his name, x and y coordinates. So if I say that player1.name equals Tom, then that player1 stores that Tom inside of it. So we store some state, and that is why our object-oriented code is stateful. However, when we're talking about functions, the code is stateless. Stateless code, which has func, and that func can have name, x and y arguments, and it can return them. I don't know what. That function can run some calculations and return those new results for. So the function can return something. That's what I mean. But the most interesting idea is that if I put, I don't know, counter here as 0, then that counter will be deleted because we don't store any state. So we have stateless code. Counter is being deleted whenever we run our function, whenever our function is finished. So when we return everything, when we delete all of our redundant variables, we also delete the counter because it's just a variable inside our function. The scope of that variable is our def func. And because of that, it will be deleted once our function is finished. However, in player, so in stateful code, in object-oriented code, we don't have that because we store our states, we store our names, our XY variables, we store other data in our objects and in our classes. But in function programming, typically we have stateless code which does not store anything. So yeah, kind of like that. We store our data in very simple primitives like, I know, for example, x, y, name equals func, something like that, from 10 to 3. And those x, y, name are simple variables that store our data. So that is how stateless ideas work. But still, if you're looking at that from the bigger perspective, whenever I call my main, x, y, and name will be deleted once my main is finished. So we don't really have a state. That is not the same for player. When we finish the creation, we still have the data inside of that object. That is stateful versus stateless code. However, in Python, once again, everything is an object. So what does that mean? That means that what we can actually do is use functions as objects. I already showed you that we can just write the name of the function and use it as an object, so get its class, get its name, and so on. However, what if I tell you that we can actually build objects inside of functions? Imagine that I have name variable here, or let me create a counter. So define function counter. Counter here, or counter value equals 0, and just a simple variable. And also I can define other functions inside of my function. So for example, counter wrapper. That counter wrapper will have non-local for counter value, and that counter value will be incremented by 1 and will return that counter value. So what is that? That is a function inside of another function. Non-local tells us that we can change the value of the variable of that function, of that variable, which is located in the function where our function is created. So I think we have a counter value, and that counter value is located in the function counter, which is the function where our counter wrapper is located. And non-local allows us to change that function. Change that variable. That is very simple. Okay, so we just incremented by 1 and return counter value. But what if I return counter value here? Or sorry, not counter value, but counter wrapper here. So counter wrapper is my function, that function. And what does it allow us to do? That allows us to save some state inside of our functions. So that counter value will be saved. Let me just show it to you. Counter 1 equals counter. Then counter 1 3 times and print counter 1. Let's run it. We receive 4. Why is that? Because if we look at the code, what I'm doing here, I don't just call while counter1 equals counter. Shouldn't I just receive the value like the integer? Well, actually no, because if we look at that code, let me just quickly remove it. So you saw 4 at the end, but if I just call counter, I receive another function, and that function is received as an object. So that is an object, as you can see, at that memory address. And what I can do with that object, since it's a function, I can call that object from, because it's a function, I can call a function. That's very normal. And the only difference is that I just receive a function as an object. And if I call it, I receive 1. So what does it mean? That means that I can save the function. So for example, obj counter equals counter. And then I can call function obj counter because it's another function which is being returned from my counter. I think you know what I mean now. And now 1, if I call it 2 times, 1, 2, and so on and so on and so on. Very, very simple. And why Python allows us to save some states in functions while function or functional programming is typically considered stateless? Well, actually, Python allows us to do that because we use functions as objects. So everything in Python is an object. So basically Python is a language that uses object-oriented programming even if you don't use it yourself. So everything is an object here. We always use an object in Python, even when we do that. Class A, class is actually an object. Let me just print it. Print A, class, name. Run it. Type. Well, type, it's an object, just trust me. So everything is an object. And because of that, what we can do is actually create objects as functions. So function is an object. So what we do here is we just create a simple value. We create a function that will change that value and we return that function. But actually, if we look closely, so if we look on that code, it's very, very similar to just a simple object creation, because as you can see, that is init. So that is kind of like init, so our constructor. We construct our object and then we call that object, object counter, object counter, object counter. And that is very, very important because you can do lots of stuff with that technique. Of course, it's not the best technique because if you're using functional programming, then it's better to stick to the stateless ideas. But typically you need, or at one point in time, you will need that idea in your code. And we can actually create as many functions as we want. For example, I know delete obj, and I can, print delete, something like that, delete. And then I can delete object here and return as a function. Now what I can do is actually get 2 functions, del obj, and let's just print del obj here. It's just a function. Del, yeah, as you can see, del here. It's just a function. So we can create objects as functions right here. That is very, very unusual technique, but still you can use it for some places because it's better to stick to normal functions and objects in Python. But what you need to know is the idea that in Python everything is an object, and because of that you can use functions in that manner. Thank you for watching. Subscribe to my channel, subscribe to my GitHub, check out my course, and good luck. But wait, before we start that video, I recommend you checking out my new course. There are lots of errors, lots of mistakes that many programmers make, and I decided to create a new course that sums up all of these errors, all of these mistakes, and gives you real solutions on how you can improve your code, improve your structure, your business, your company, and so on. And if you want to write better code today, then just check out that course. I, of course, mentioned lots of things in my YouTube videos, but if you want to get into details, then that course is for you. So just check it out, link is in the description, and let's continue with the video.